Questions on that one? All about knowing this little motion right here. I don't know what to call that. You guys got a good name for that? The curvy thing? Curvy thing sounds good. It sounds kind of weak, but we could probably call it. Maybe we could give it like a Greek name so we sound smart.
So what's the Greek word for curvy?
Why don't we just call it,
Secant.
let's call it the flip-flop.
Flip-flop, there you go. But then we gotta put like a Greek letter, but we'll call it the zeta flip-flop. And we're gonna go, oh man, did you hear that? They're doing the zeta. See, that's the way mathematicians make themselves look better. They've used Greek letters so they confuse everybody. And they do simple things with it. Okay. The zeta flip-flop. Where are we? Oh, here's a really tough one. So I want you guys to think about this. Log base 6 of 36. What does that equal?
Oh, 2.
Right? It is that easy, isn't it? Of course.
Put a lot of those in there.
Of course it's 2. Log base 18 of the square root of 18. Well, that would have to be 1/2 because then we would get this zeta flip-flop. Would like to solve an equation here. I'm actually going to add one here, so I want you guys to look at this. 5 raised to the x minus 2 equal to 1. That's that problem from the board. And then we're going to do over here 5 to the x minus 2 is equal to 2. Two different problems. That one's on the review. This is one I just made up. How do you solve these problems? Well, this one, you actually say 5 to the x minus 2 is equal to 5 to the 0. What is 5 to the 0? 1. Right? So that's the same as this. And then you can drop the base and say x minus 2 equals to 0. So x must be 2. And that's perfectly easy to see. 2 minus 2 is 0. 5 to the 0 indeed equals 1. Now you come over here. How do I do that one?
You flip-flop them?
What do you mean by that?
I don't know.
Divide by 5.
Divide by 5. It's the same problem, isn't it? Actually, it's not. The idea here is that you cannot write 2 as 5 raised to a power, unless you use some kind of decimal freaky power thing. But as far as like a number is concerned, a digit, no. If you can, let me know, because I'll go home for the rest of the day. What you'll have to do here is take the natural log or the log or any log you want, but you might as well use ln since we have it on the calculator of both sides. Because when you take the natural log of both sides, what can you do with this x minus 2? Pull it out front. This becomes x minus 2 times the natural log of 5 is equal to the natural log of 2. And I divide by the natural log of 5 to get x minus 2 equals the natural log of 2. Divide by the natural log of 5. And finally, to get x all alone, ln of 2, ln of 5 plus 2. Entirely different problem, very similar. Okay.
Isn't that the same as if you divide by 5, right? Because you get 2 and 2 fifths for the answer.
if I had x minus 2 times 5 is equal to 2, and I divide both sides by 5, I will get what you're looking for. But this is not 5 times this. This is 5 raised to this power. You see the
Yeah.
difference? If you divide by 5, it will do you this. It won't do you much good at all. You'll have 5 over x minus 2 would become 5 to the x minus 2 minus 1. So at 5 to the x minus 3. It would not be very useful. I think it's a coincidence that you got a similar answer. Seriously, because it would not work out. You cannot divide the exponent away. This is not multiplication, this is a power. We should check to see if this answer works. 5 raised to the 2.430676558 minus 2. What should this equal? There's x right there. See? This calculator says it equals x, I'm going home. Raised to answer minus 2. Should be 2. If it wasn't 2, then it wouldn't be a solution to this equation. But since it is 2, I feel fairly confident that that is indeed the answer to x. Questions on what happened between these two problems? In general, you can't write one side of the equation with the same base. In general, that's something that has to be almost thought out in advance, right? Of course, it could happen, and 1's a good number because you can write 1 as anything raised to 0, so if you see the number 1, you're in business. But other than that, and some other weird numbers that might pop up, you're generally not going to be able to write this side of the equation and this side of the equation with the same base. So this technique over here is sort of a rare event in the actual solving of equations. It is more likely to come across something like this, where it doesn't work out, and you have to use the natural laws. Okay. All right. Let me just take a look at a couple more here. Maybe I'll jump right to the end. The rest of this stuff I feel you can handle pretty good.
Can you do 18?
I will. Let me just say something about 25 real fast. Take a look at the last word problem. This word problem is not like the ones given to you on the handout. What is the difference?
It's got fish in it.
It's got fish in it. That's a great answer. This is the only one that has fish. The difference is that the equation is already given to you. You are not creating a function at all. The function is handed to you on a silver platter and says p of t equals this god-awful looking function. But did you create the function?
No.
Now all you have to do is solve that function when p of t is equal to 1289. Solve it for t. So this is a different beast altogether. So when you say, will there be word problems on the test, there'll be a couple like the handout I gave you prior to this, and maybe one, if not two, like this. I'm not going to tell you this is the one you have to make a function for, this is the one you don't have to make a function for. I'm going to leave that one for you to decipher on your own. Okay, sorry about that. Number 18, was that the one you asked me for? Number 18 is log base 3 of 21. Minus log base 3 of 24 is equal to log base 3 of 21 over 24. That reduces down to 7 over 8, so log base 3 of 7/8. Is that one of the answers?
Yes.
That's
Oh, it's just as simple as that.
every one of them. Okay, I'm done. You guys have a great day. Have a good weekend. Take your test on Tuesday. Get here early if you want to. And then you have the entire week off after that. Wednesday, Thursday, Friday, Saturday, Sunday. What will you do? At 1/2 to the x. This is y equals 1/2 raised to the x. Standard exponential growth with the base of 1/2.
Okay, now can you see the base in this right now?
You cannot.
Okay,
Not any
this is an approximation.
approximation, but notice it goes through 0, 1 right here. That's important. And then if we wanted to pick a couple values,
And they all go through 0,
At
1,
one-
and then, right?
I said the wrong thing anyway, so can you back that up? Go ahead and back that up.
We'll put it in the blooper reel.
Blooper reel. This is not exponential growth, this is exponential decay, because this is less than 1, remember?